Hello and a warm welcome to this week's video, and it's not a running session this week. We're going to have a workshop update. I'm sat here, I've got a few items on the desk I'm going to talk to you about. So let's start off. I don't know whether you can hear the mains hum, but I've got a little old Triang power unit here. I'm going to be using this for a couple of tests. I've got a Ginty on the rolling road. Let's just prove it's connected, which it is. So I'll just turn that off. So I've got a couple of things to show you today. In a right state is this Gaugemaster controller, which I obtained last year. Someone had already taken off the base, drilled the rivets out, and cut the mains plug off. Now I know these have a lifetime warranty, so why they didn't send it back to the factory. I think it's because on the box, scrawled in felt tip, it does say water damage, so I don't know whether water damage would be covered by that, probably not. But anyway, I inherited it with it in this condition, and unfortunately no control knobs, but I've been very lucky to be able to pick up 4 control knobs, so that's sort of spurred me on to try and get it going. So we're going to come back to that a bit later in the video. The reason I'm wanting to get that going is because it's given me a bit of an idea about using these little volt and amp meters that I got some time ago from abroad. They're really nice looking little things. Let me demonstrate this to you. They've got a couple of little plugs that you plug in. So firstly we'll have a look at the voltage. So I've got to put all the wires in. There's a couple of different ways of wiring these up, you can see on the internet, but I'm opting to hopefully get voltage and amp reading when I utilise it on the railway. So I'm just going to, just bear with me while I get these held on with my finger. Seems to be all fingers and thumbs. Right, well I hope maybe you can see that now. Any flicker you can see on the video is actually the refresh rate of the video. In real life it doesn't seem to flicker like that, but you've got, well, upside down there I think. We've got the blue digits at the bottom, which are going to measure the current consumption, and the red at the top, and you can see it's just under 9 volts, which would be about right for this battery because it's been in a smoke alarm for a year or so, so it's pretty much exhausted. Now, I've been playing around with this a bit, so we'll start the 3F up. And I was quite confident that I'd be able to just connect this straight up and at least see the voltage. And I'll show you what happened when I connected it. Now I hope you can see. I'm just gonna... Now what we're getting is just a lot of flickering. The display flickers and everything zeros. So that leads me to think that this controller is just not putting out a very clean DC supply. In fact, I've tried it on my clippers up at the layout, exactly the same. So I was a bit disappointed about that, but never going to give up. I decided, well, if it's only a smoothing problem, dirty DC from the rectified output, maybe I'll just smooth it out with a little capacitor. So I've got a few capacitors lying about, and I just decided to choose this electrolytic. It's rated at 35 volts, so it'll be safe for everything that this can put out. And it's left over from when I was mending the Hornby H&M 4000. I bought quite a few capacitors and I had a few left over. So it's a, is it 470 microfarad, something like that. Anyway, there's a really interesting thing that happens. I'll plug this into the fish plate. I wonder if you can hear this. Perhaps didn't pick it up on the camera, but as soon as I put that capacitor to smooth out the DC, we get an immediate improvement in the running of the loco. Now that really sort of more or less confirms that the rectified output isn't particularly clean. Okay, well I wonder if this has cured it. Well, I think you know that I'll have already tried this, but let's plug the little meter back in. Now I know the camera's a little way away from that, so You perhaps can't see it, we'll be taking some close-ups later, but that's actually now settled down nicely. The amp reading is obviously 0, but we've got a reading now of 12.4 volts, so let's turn it down, and indeed the voltage is dropping right down to sort of 6.5 as it stalls. Start it up again, and it's running quite nicely and slowly, and we've got 9 volts. Now I've tested the accuracy of the little meter with my multimeter and it's nearly there, but there are a couple of small potentiometers on the back of the meter, so you can fine tune the voltage if you want it to be really accurate. So anyway, that little capacitor has meant that, yeah, I think I can use this on the layout. So I'll just leave that there, just turn it off for a minute, and I'll show you one I made earlier. So it's the same unit. I've got 2 because I want one for the upward line, one for the downward line. I've soldered on permanently rather than using the multi-plugs, the wires I need, and I've incorporated the electrolytic capacitor in the back of the unit. Now I've got 2 of these, the one we've just seen and this one, so hopefully one for the upward line and one for the downward line. I've had a hunt around the workshop and I found this old metal casing from a destroyed lithium battery charger for the model aeroplanes, and it's really nice. It's sort of quite nice aluminium. That's the front plate. Well, that's no good for me, so I've cut another piece of metal which will slip in. Hold on, let me just see if I can get it in the right groove. So that's going to be the new top for the unit, and then I'm going to put the 2 voltmeters side by side, and I've got quite a bit of room in there, so I'll put them near the top. I've marked it at the back because in the future, if I wanted to add another meter for the branch lines or something, I could do that. So this will tidy up the meters and look quite nice next to my point switches and give me a lot of information about what the current consumption is of whatever I'm running. Now, there is a slight problem with these meters. You cannot use a reversed polarity, so they only work in one direction, but I've already thought about that, and if I can coax the unit here into life, we've got a forward and reverse switch on each of the main lines, so I'm going to intercept the current at the switch, so I just maintain negative and positive, and regardless of whether it's running forwards or reverse, my amp meter and voltmeter will be reading. And the extra wires, there's some spare terminals on the back which I can use, and I need just a couple more, so I'm going to affix a terminal block on there and just hardwire these to the circuit board and make it so I can wire everything in on the back. But we'll come back to this in a minute because I've got a bit more to add on that. But what I'll do now is I'll pause the video and fully connect in the other amp meter to the little Ginty to give you a demonstration of not only voltage but current draw. So let me just pause the video and connect up a few wires. Okay, well, I've just connected in the second of the meters. I've left the first one there. I've put a bit of blue tack underneath just to hold them to the desk, and I'll apply a bit of power. So as you can see, they're both reading similar voltages, but we've already got a little bit of current draw. So let's get the engine running. So there goes the Ginty. Slight difference in the voltage between the 2 meters, but it is adjustable as I mentioned before. And on the left hand meter, which I've already hardwired, we're measuring current as well. So hopefully you can see it's drawing 0.18 of an amp. Now I have confirmed that with my other multimeter, and that is accurate. Now this is a very well serviced loco, remagnetised, and this is a sort of optimal condition for a triang motor. They draw between, in ideal conditions, sort of between 0.2 and 0.4 of an amp. And of course it's not pulling anything on the layout, so it's under no load. So it would draw quite a bit more, I'm sure, when we get some wagons on. But that's what I'm aiming for with these little meters. Something for the upward line, something for the downward line, just giving me an idea of what the motors are doing, and it'll be interesting to sort of look at double heading and other things we get up to on the layout. I know they're a bit sort of gimmicky with the bright colours, but I kind of think they're going to be a useful addition to the layout and great for a quick spot check on a loco's health. So if I just turn that right down now, off. Now obviously I can't do it backwards because that would reverse the current, and I mean, there's some protection in the meters, but you don't get a display. So that's why we're going to move on and have a quick look at this Gaugemaster controller. Okay, well, I'm quite happy with the way these are working. So let me show you what I've been up to with this Gaugemaster. Right, so I've tidied away those little volt and amp meters just for now, and I've just made a start on the Gaugemaster. So I've fitted a nice new plug, and a proper modern type plug with the insulation halfway down the contacts there. Don't be tempted to use old plugs. And I'm going to do a couple of basic checks. Now obviously this isn't plugged into the mains, this is quite safe. I've got my multimeter, and the first thing I'm going to do is just check the earth continuity, because this is earth to the case, so that's quite important. So let's have a look at that. So we know the earth wire's alright, and then I'm going to check both negative and positive to earth to make sure there's no short circuits, and that's looking good. So these are good initial tests, and then I'm just going to see what the internal resistance is. So we've got a resistance there which shows that the transformers, there's two transformers in this, aren't open circuit. Right, well, I think we'll move on to the next stage of testing now, so just bear with me a sec. Now, most of you have got multimeters, but you perhaps won't all have a pat tester. Don't worry if you haven't, because I'm sure you've got a friend, or you can find an electrician who can do this for you. But it's really important, before we even think about putting any current in this thing, that we give it as much thorough testing as we can. So I'm just going to put the cover on the plug. So there we go. So because this is a class 1 test I'm going to do, I've got an additional earth clamp here which I'm going to put onto the inside of the case on a metal terminal, because part of the test is to test the earth continuity. So in goes the plug. I'm going to set it for one class 1 test and click the start button and see how we go. So the machine is now going to firstly test the earth continuity, and that's passed, and then we're going to have an insulation test which is passed, and then the current leakage. Well, that's passed as well, so that's very, very encouraging. I think we're getting to the point where we might think about plugging this in. Right, so I'll just put the pat tester away. Any old train transformers you've had at the loft, or you're dubious about the condition of the power lead, do get them checked out. I'm lucky enough to have had some electrical training back in my youth. Another one of the things that I did another lifetime ago. So let's think about getting this plugged in. Now, before we even consider plugging it in, I've got a safety cutout that it's plugged into, and I need to get the case safe. So I'm going to assemble the case, so just bear with me while I take this off camera just for a second. We are not going to attempt to operate it with the case open. Okay, so before I plug this in, let's see if I can just get that more into view. I'm going to set both these simulator switches to off and the forward and reverse switches into the central position, and I'm going to turn down the 4 potentiometers to the most left position. Right, well, here we go. I'm fairly confident there won't be a bang. It's passed its PATS test. Yep, so it has indeed powered up. Now there's a slight mains hum. 2 red LEDs on the display, one there and one there. So I think the first thing we'll do is test the fixed output. So I'm going to test the AC output first. So there's going to be, now excuse me, I'm just going to turn it round slightly just to see the terminals on the back. Let's just reroute that. Whoops, upset my solder, mains lead. So on the back here we've got 2 terminals that say spare. We've got 16 volt AC, 12 volt DC and track 1. So let's test the AC terminals first. So on that one, that's saying just over 23 volts. That one, 23 volts. So we've got 2 AC outputs. That's looking good. So let's now check the fixed DC output. That should be there. Well, that's coming up as 15 volts. You can tell it's DC because the polarity was observed on the meter. Okay, and this side. Right. Okay, I guess the final thing is there any output on the track side? So I'm just going to switch it to forward, turn one of the knobs. Well, there's definitely something happening on that left controller. Let's try the right controller. Yeah, we've got, amazingly enough, output on both the controllers. So I think what we'll do now is I'll just pause the camera for a minute and I'll connect up the little jinty, the rolling road, to the output on controller 1. Okay, well, I hope you can all see. I'll prop this up. I know it's the wrong way round, but I just want to keep an eye on the wires. I've got it wired up to the little jinty. I've put a couple of the knobs on and they fit nicely, so I'm pleased with that. So I'm going to select forward on the direction switch. Just before I turn it up, if you're all wondering what that noise is, or noises in the background, it is all the clocks in my workshop ticking. I might have mentioned before that I do indeed mend clocks for a living, so there's always lots of ticking going on. Apologies if they're disturbing the video. Anyway, back to this. So I've got it set to forward, and I'm turning this the simulator is off. I'm turning this main controller knob past 20, 30, 40. Now as I approach 40%, I notice the LED is changing colour. That's a good sign. And at 50%, indeed, the little jinty is starting to run. Now, I don't know whether modern locos, they probably have, with the newer motors, they perhaps can start at a slightly slower speed, but so far it seems that if I go back to off, start turning it, yeah, I need to get to 50 to get going. Now, It's a bit different from my H&M clipper I've been using on the layout, because that's got a resistor in series with the 12 volt. It's kind of quite linear. This one seems to have got sort of a curve built into it, probably because it's fully electronically controlled, so we haven't got very much up to 50, and then it starts, and then it's quite nice all the way up to full power. Be really interesting to see how Hornby 00 and Wren locos behave as well. Okay, well, the main controller seems to be working. Let's try this simulation feature. Let's set it at, say, 80, and that stops dead because that apparently this brake control is fully applied, so I'm going to turn that round to release. So the main control is on 80%, and indeed now we've got a type of inertia start, just like the HM4000 I featured in a video some months ago. I'll put a link to that. It was a great controller, I enjoyed using it, but it had a bit of a strange side effect on some of the Triang locos especially, where you get a really high frequency noise coming out of the motor as the inertia kicked in and out. I guess it was a kind of oscillation through the windings of the motor, but it wasn't particularly pleasant, and it's one of the reasons I put it back in its box and went back to my clippers. I just found it almost giving me a bit of earache. I did read on a few forums that some other users have had that issue too, so I think it's just peculiar to the controller. Right, let's just put a bit more. Let's turn this anti-clockwise, this brake, and just increase really fine levels of control. I'm looking forward to getting this on the layout. I think it's going to be very interesting. And the other thing I want to find out is whether it's got any sort of current compensation, so if the load varies on the engine, if there's a slight incline, or it measures the current consumption slightly increasing, whether it'll increase the power. So that's something to investigate as well. So if I turn the main controller to 0, indeed it decelerates in a really nice slow fashion. I'm going to be looking for the instruction leaflet for this now online. I'm sure I can download a copy, become more familiar with it, but I don't think there's any need to connect up the second side. I'm sure it will be working. The first test showed there was current there. If not, I can trace the fault, no doubt, and just compare it to whatever's going on with this side. We'll finish this video in a second. I'm just going to unplug this all. This is going to be the point of interest in a minute, this forward and reverse switch, because I'm pretty sure that the power from the controller will be going into this switch, and then this will just provide a way of turning the polarity backwards and forwards, so it switches completely to affect forward and reverse. Now obviously I can't connect my new little meter where the track wires go, because it'll only work in one direction, and when we go into reverse the current will, well, the voltage, it will be reversed and the meter won't work. We tried that earlier. But if I intercept on the circuit board where the power goes into this switch, I'll be able to wire my meter in. Now my meter works on the negative side of the circuit, so I'm just going to investigate where the positive and the negative go into this switch, and then we'll have a quick look at where I'm going to put the wires in. So I'll just get this turned over, unplugged from the mains, and we'll have a look at the circuit boards. Okay, well, just to end this video, let's see if I can get that. It's difficult to see the camera. This is safely unplugged from the mains, and I'm looking at two identical circuit boards, left and right. It's got a separate transformer for each circuit board, so quite a lot of power available, I would imagine. So looking from the underneath, this section here is the voltage selector switch. So we've got 6 terminals, 2 there, 2 in the middle and 2 on the right. So the power goes into the voltage, the direction, selector switch, the forward and reverse, in the centre. And that's the same on both of them, obviously. So I did check with my meter in extremely safe conditions which was negative and which was positive. So that is the negative and that is the positive. Now the amp meters that I showed you earlier in the video are wired into the negative side of the circuit. So we've got two spare pieces on the output that aren't used. They're disconnected from the circuit board. They must have designed them with a use in mind, but they're not used. So what I'm going to do is I'm going to have the ammeter across these two terminals. So I'm going to interrupt this track somewhere where I've marked it in pen. Just take a segment out of the track, not too wide, so if I want to return it to original condition I can just bridge it with solder. And then I'm going to run one wire from that solder pad there to a spare terminal, and then let's have a look, a wire from that solder pad there to the other spare terminal, a cut in the track, and then connect my ammeter across that, and that's going to give me current draw whether it's in forward or reverse. Now the little voltmeter needs a positive 12 volt supply as well to measure. The positive is on the other side, and that's where my extra terminals on the back will come in, because I need a positive 12 volt from each forward and reverse switch to each ammeter. So I'm going to make a little terminal block on the back, route the wires and insulate them very well. Okay, well I hope you've enjoyed seeing what's going on in the workshop at the moment. These are the two sort of main things I've been working on. It's a long time since I've tried a different controller on the railway. I did experiment with the HM4000, so I'll see if I can find a link to the video that I did with that controller and put it in the description area. Since then I have been just using H&M clippers, and I'm really happy with them. They're great controllers and they suit the sort of age and vintage of my layout. But I just couldn't refuse giving this a try for the price. And well under £40 including postage, and that includes the replacement knobs as well. So I think I've had a bit of a bargain there, which makes a change, because sometimes bargains aren't all that they're cracked up to be. Well, I'm going to look forward to getting this all set up for the next video and running some locos on the main Super 4 layout. I've still got the locos on from the last video, the City of Glasgow and the L1, and also I've got the long freight trains. So once I get this all wired in, we'll have a really good video seeing how this performs with the old Triang and Wren and Hornby 00 locos. So I'll just reiterate again, if you're doing any work on mains equipment, unless you've got relevant training, please do find someone to help you with all the testing. It will give you peace of mind and, you know, freedom from worry about whether something's safe or not. Because I mean, lots of these old controllers, the power cords, they can become very damaged, and that's even more of a worry, because if it's plugged in and you've got a break in the insulation, you could be straight onto the mains, and that could lead to all sorts of problems for you. Right, well, until the next video, and we're using this up on the layout, I will say goodbye.